Good morning, everyone. Hope my voice is clear to confirm. Is my voice reaching to everyone? Can it be confirmed, please? There is no response from the student side. Background voice is only audible. My voice is not audible. Many said yes. Yeah, there is a background disturbance. Leave it apart. No audible. Correct? Okay. Without wasting much time, I want to quickly start. I'm not going through any chat now. If at all any chat is there, please raise your hand. I will get back to you. So, pulling it aside, we have gone through what is database system. We have seen what database system, and we have seen the 3 levels of database abstraction, and we were about to start with the database. So quickly jumping on to that particular topic now. So you have seen that database is a collection of related data and a set of programs that access that particular data, and also a collection of environment that is both to use. Environment in this sense, a set of tools and utilities which will help us to access that particular data, stored data. So in a overview, database management system is a collection of data plus a set of tools which work together to provide easy and convenient access to the user. Now you have seen various examples of database applications. Then we have seen prior to database management system, what was the earlier system adopted in the computer industry. The earlier system that was adopted in the computer industry was file system. The data used to be written in terms of Word files or Notepad files or PDF files or some sort of files. And now that file system still exists. There are certain drawbacks in that particular file system, and we have seen clearly what are those drawbacks. Just to remind it, first drawback was data redundancy and inconsistency. Data redundancy and inconsistency in the sense, if I am trying to save the data in the file system, I will save the data in multiple files. Today I will save the file with the name as today's date. Tomorrow again, if I modify it a little bit, I'll change the date and still I will store with a new date, and like that I'll go on. But the problem in that is, if I continue in the same manner, multiple files will come into existence, and suppose if the dates are not being maintained, file 1, file 2, file 3 system is being adopted. That particular notation is adopted, file 1, 2, 3, 4, so on. Tomorrow, suddenly, after a gap of 10 days, if I come back and I see what was the eighth file going to contain, I will not be able to justify whether it is the updated one or the 10th one is the updated one. Though I can say 10 is a numerical value, but I'm not having any assurance. I open the 8th file and I may have updated it. But there is no assurance that that particular file is the updated. So I will have multiple files, plus those files will not be consistent in nature. Consistent means having the same content or same level of information throughout that particular sequence of files. So first drawback. Second drawback was that when we are using multiple files, data isolation coming into existence. I will use multiple files to store the data. At the same time, when I'm using multiple files, I will store that particular files at different locations. Sometimes I may gather the data in my flash drive, or sometimes I put it into my laptop. Sometimes I may work on desktop computer, and I will scatter the data into multiple locations. Now, suppose I work tomorrow. I am coming and utilizing my desktop, but I have already wrote down my laptop. So that data which is stored in laptop is not available in desktop now, unless I make a backup copy of it. So this type of problems were existing in case of file systems. Another problem was data integrity. Now suppose I am entering the data in the while entering, I forgot, like for example, phone number. 10 digits. I forgot to enter the 10th digit by mistake. Is there any condition checking mechanism which will tell me that you have not entered the 10th digit? No. There is no conditional checking mechanism in case of our file system. But whereas in case of database management system, we have got programming features embedded inside it which will check for the particular nature, whether a particular value is correctly being entered or not, whether it satisfied certain constraints or not, all those things. Another problem is atomicity. Atomicity means if a particular value that is to be entered, if it is splittable, splittable nature is not called as atomic. For example, we have taken as name into first name and last name. So name is not atomic in nature. Whereas first name and last name are atomic in nature. So when we are saving data in terms of files, I may put the entire thing as a description in terms of paragraphs. When we write into Word or Notepad file, usually we'll put paragraphs or bullet points or something like that. But in case of database management system, you store the data only and only in terms of non-splittable values. That means only values which cannot be further classified or categorized. This introduces a very important feature which says that if the transaction should happen, it should happen in totality, otherwise it should not happen. For example, you are withdrawing money from your ATM account. You have tried to, you have inserted your ATM card and you have mentioned your PIN, and then you have entered that to withdraw 10,000. Now when you clicked on the button for withdraw, enter, after typing the 10,000, power supply went off. What will happen to your transaction? You did not receive your money. What will happen to the transaction? It went to the bank. The transaction have access to your bank details. It has reduced the bank amount, and while giving the cash in the outbox, the power supply went off. So should this transaction uh, be successfully done, or should it be reverted back? Normally, it should be reverted back. So that nature of having a checking whether the transaction should happen in totality, if it is to happen, or it should not happen at all, is not there in file system, but it is there in database management system. Another problem is security. So while entering peep from my shoulder and see what is or what I'm doing in the file. Suppose a particular file system is containing your login information. That's all visible to the observer or people who is seeing that particular data. But in case of database management system, when you access, you will access only a atomic value, either the password or the username or a particular thing. Remaining things will be hidden. And in case of DBMS, specifically for Oracle doesn't release any password to anyone. Not even number of letters that we are typing is not visible. It's hidden. So this is the problems faced. These are the problems faced as drawbacks of file system. Because of these drawbacks, we are learning the new system, which is our database management system. Now, when we are talking about database management system, first of all, let us see what is data and how we are going to manage that particular data. Data is to be considered at three different levels when we talk about its architecture. The first one is abstraction. In case of abstraction, the first level is physical level. Second level is logical level. Third level is view level. Physical level means, for example, when you are saving a particular value, let us say 10. Inside your computer, you have computer configuration as 32-bit configuration or 64-bit configuration. Your processor will be accessing inside your processor there will be data pins and memory pins. Those data pins, if they are 64 in number, it is called a 64-bit processor. If it is 32-bit in 32 lines pins, then it is called as 32-bit configuration. So based on 32-bit configuration or 64-bit configuration, our operating system is also classified into 64-bit operating system or 32-bit operating system. When you are saving 10, value 10 in the system, practically you will hide the details from the normal user whether it is being saved in 32-bit configuration or 64-bit configuration. For example, once you college starts, you will apply for e-pass for bus tickets, bus pass. Now, when you are applying that particular application online, do you really know you have entered your year of study? Is that year, second year or third year, really being saved in 32-bit configuration or 64-bit configuration? We don't know it because we don't know practically how the data is being saved internally. It's hidden from normal users. That hidden nature is called as physical level abstraction. Second level is logical. Logical level says it's not clear. Okay, I hope my voice is clear now. Okay, let it be. Maybe the voice is not so clear due to internet problems. You can go through it on YouTube also later on and get to know what I was speaking at that moment. So I don't want to waste much time there. Logical level means you are trying to hide from normal user as a developer what is the actual data type used to save the data, or what is the actual content of the data that is being saved. For example, I'm storing the database of, let us say, students. Now in the students database, student name, pin number and name and marks 1, marks 2, marks 3, so on to marks 6 are important for you. But when you see the end result scorecard, you will find not just the name, pin number, and your marks of individual subjects. You will also find what is the total. You will also find how many credits you received. You will also find the certificate number. You will also find what is the class of uh, passing, for example, first class, second class, or others. So those are also values. Are they being saved inside the database, or are they being calculated somewhere else? That particular information, what is actually being saved, is hidden from normal user. This type of hiding is called as logical level hiding. View level hiding is based on who is viewing it, will hide the content of the data that is being displayed in the window. For a normal user, we'll give as per the user's requirement what is to be displayed. For a sophisticated user, we'll give some more detailed view. For a very well versed administrator, we'll give more details to be viewed. So these are the three levels of abstractions that are so physical level, how the data is actually being saved, logical level, what is the data that is being saved, and view level, who can view the data. Now instances means these two are very similar to or analogous to your variables and uh, data types. Instances are the database values at a particular moment of time. Do remember at a particular moment of time here is very important. When we say schema defines a logical structure of the data that is being saved. What values exist at a particular moment of time? It's the instance. Schema is what is the logical structure defining that particular values. For example, for a variable, the value may be 10, but that variable's data type, integer, float, character, double, all those things are the schemas. So those things are there. Now there is a logical schema, there is physical schema. Logical schema means we describe only about the logical orientation of the variable. For example, int x. We have int x. But there are two more categories of int x. One is 32, another is int 64. Are we really saving the values in int 32 or int 64? That particular details are physical level schema. Logical schema means only int over there. The computer program compiler, it takes whatever you defined as int x or what, int y, and it converts based on the computer's need to either int 32 or int 64 based on the internal configuration. But explicitly also you can mention whether you want int 32 explicitly or int 64. If you are well versed with the computer environment, you can use it. So those two are logical schema and physical schema. Now there is data independence coming into existence. I'll be back. I'm sorry for the inconvenience, ma'am. Let's back again. So physical data independence means if we are able to change the physical location and physical structure of the data that is being saved. If I have a computer which is 64-bit configuration, that int will become internally as 64-bit. If I have a 32-bit configuration on my system, the int x will become int 32x. So if I am changing the internal structure and it doesn't changes the logical structure, then it is called as physical data independence. The ability to modify the physical schema without changing the logical schema is called as the physical data independence. So next we have got data models. Data models are nothing but representation of the actual data to be saved in some form. That form may be either a diagrammatic form, or it may be some descriptive form, or it may be some representation in terms of variables, some representation in terms of objects, some representation in terms of fashion. So when we talk about data, when we are saying the data may be a numerical value, the data may be a alphabetical value or alphanumerical in nature. So all that data which is there should be, or the data may be any literal in the sense anything whose meaning remains fixed irrespective of any application. For example, if I say yes or no, yes is a literal here. Its value is universally same. It cannot be changed to no. Similarly, null. Null is constantly null in the computer industry irrespective of any other applications. So this data, whether it is numerical, alphanumerical, or character oriented, or a literal, or anything like that, should be some way interrelated in nature. Second thing, when we say interrelated, we say they are related through some relationship or association. So data model contains the data that is to be saved as well as what is the relationship or association that exists among them. Next, what is the semantics of the data? I'm saving some numerical value of 10 digits wide, but the 10 digits number is actually a phone number for me, right? But it may be something else also. For example, your PIN number, it's 13 digit wide. I'm telling that there is something 16054 some number, but that number means to me not just numerical figure, it means a particular student who is there in my class. So there is some meaning behind that number. So that meaning is called as a semantics. Data constraints. Next thing that it contains is very important, which is constraints. Earlier we have seen in the file system that when I am trying to enter the phone number was 10 digits wide and we entered only 9 digits, and there was no facility in the file system which was ping us back again telling that you have not entered 10 digits wide phone number. Similarly, salary of a person. Salary is around 3 lakhs. By mistakenly, I removed two zeros from it. So it normally becomes 3,000. Should it be the case? No. It should give certain warnings to me telling that that particular value should be 3 lakhs or greater than some initial value like 30,000 or something like that, and it should remind me that we have not entered proper values. So this checking mechanism is called as constraints. Any condition which is kept is called as constraint. So data model actually contains what is the data, what is the relationships that exist in the data, what is the semantics behind the data, and what are the constraints that we have kept. So to have the data models, as I said, data models are representation of data in terms of some diagrams or in terms of some description or in terms of some numerical variable values or in terms of some objects or in terms of some tables. So the first and foremost diagrammatic representation is done through entity relationship model. So entity relationship model usually contains some notational figure notations which will represent a fixed meaning behind it, and using those diagrams will draw certain things, just like your flowchart, how you used to draw it. Similarly, we have got another which uses a way of storing the data. This tabular way of storing data is Tables in database management system are also called as relations. It's not the same as a relationship. Relations means tables. Relationship means associativity between the various files. Now, model saves the data in terms of usually tables or each table is composed of various columns. Those columns are actually the attributes of a particular value which you want to save. For example, if you are saving the data about a student, name, pin number, marks, total, aggregate, all those things, percentages will become the column headings. Those column headings are the attributes or characteristics which define the student. Now each row value which is being entered, row 1, row 2, row 3 for one student is actually the tuples in the relation or rows in the relation. Tuples in the relation terminology or rows in terms of table terminology. Just give me 5 minutes, I'll be back again. Sorry for a small disturbance now. Let's get back. So we were talking about relational model. So relational model is basically composed of tables. Each table will contain certain column headings and certain rows. Each row will be for one specific student as we have taken that example. So each row is actually called as, in terms of tables terminology, it's called as row. In terms of relational terminology, it's called as tuple. Okay, in terms of table terminology, the columns are called as columns, but in case of relational terminology, those columns are called as attributes. So we'll be using one term for the other in somewhat mixed manner. Sometimes when I talk about a table, I'll say it's a relation. So you shouldn't interpret what I'm meaning from there. Okay, it's easy. Don't get confused. Third model which exists is object-based is, since I told you that the data can also be saved in the computer in terms of objects, there are many object-oriented language languages which are existing in the market. Like one of the most beautiful language is Java. So when we are talking about Java, it's not just one programming language which is built for some logical computing. It is a language which can even connect to the database and do some manipulations in the database. So when I'm connecting the Java language to the database, I can save whatever Java values that were computed through the program back into the database. So the values that are computed in the Java programming language are actually objects. So when I try to save back the objects into the database, they should be saved back as objects. So object-based data models are also needed to save those type of data. The fourth one is semi-structured data model. This is a little bit descriptive format of your data, and this descriptive format is usually meant for translating one format of data into another format of data. For example, I have Oracle database being maintained at my company's end, and another client's location I have got Microsoft database. So these two are two different companies and they have their own standards. There should be some way to translate my data back into Microsoft's data so that it can be used at the client side. So that translation mechanism is done using XML, not just Oracle to Microsoft, many other languages, many other companies, databases are there which need to be translated and integrated. So for the translation and integration, we'll be usually using the XML, Extended Markup Language format, which is a semi-structured format. Now, the last one, there used to exist models also. These other models are usually used, we are using some network mechanism. For example, on my laptop, there is a Oracle database installed. Now, in the college main server, there is one more Oracle server installed. Like me, there are multiple faculties. They have their own individual servers, Oracle databases installed in their laptops. Now, all of them they want to plug into the main database server so that whatever is there inside here can be replicated back there, and from there the data can be synchronized back into our laptops. So this mechanism of having some one main server and then sub servers is actually a hierarchical manner. From my laptop, it may be my home desktop, something like that. That hierarchical mechanism of storage of data is actually called as hierarchical model. And also, since I am using a network to link up my laptop to the main server, I'm also calling it as network model. Okay, clear? Now, those were the models. Let us quickly get into what is entity relationship model. Entity relational model. Now, this entity relationship model, data model, is a diagrammatic form of representation of data. But let us first get to know what we can put into diagrams. Basically, the name itself says what it can say. It can save the entity and it can save the relation. So let us quickly get into know what exactly is the entity. These are the two basic objects which are entity relational model, ER model. So entity in general perspective is anything that exists in the world and can be distinguished from other objects. Anything or object that exists in the world and can be distinguished from other objects is called as an entity. This point should be very clear for you, man, because based on this only the entire subject is. Entity is a simple thing. It's anything that exists in the world and can be distinguished is called as entity. For example, this pen, it is an entity. My mobile, it's an entity. Myself, I am an entity. So anything that exists in the world and can be distinguished, living thing or non-living thing that can be distinguished from others is called as an entity. So now the point is, what is relationship then? Any anything that can be having some association with others is called as a relationship. For example, this I'm using this pen. Using is a relationship to this association to this pen. Is one entity, myself is another entity. I'm using this pen. Using becomes my association with this particular pen. Similarly, this mask is there. Mask is one entity. Myself is one entity. I'm using this mask. That's another relationship. Student is there. College is there. Student is one entity. College is another entity. What is the relationship between them? Student studies in the college. So that's an relationship. Students are there, marks are there, student achieves marks, that's a relationship. Faculty is there, marks are there, faculty awards is a relationship. So there are two things basically, one is entity, another is a relationship. Entity is anything that exists in the world and can be distinguished from others. Relationship is the association among that particular entities. So now, how do you define the entities? If you want to define me, I have particular height, I have particular age, I have my name, I have got my complexion, I have got my living habits, place of birth, everything that can be used to say that yes, this particular person is different from other persons. So those things which are used to define me are the characteristics which you'll use to define me. Those characteristics are called as attributes. So entities are described in database by a set of attributes. For example, for a student, name, pin number, marks becomes the attributes. Similarly, for an association, there may exist some attributes or they may not exist some attributes. We'll try to avoid keeping attributes to relationships, but you can mention the attributes also. For example, person is there, bank is there. Person borrows loan. Borrows loan is the relationship. What is the loan amount? What is the loan number? What is the duration in which the loan is to be paid? Those are the attributes that will describe that borrow loan. But if required, we'll use them. If not, we'll try to avoid them. So now it's clear what is an entity, what is a relationship. Now those entities which are of similar nature, which have same almost same characteristics, those characteristic values may differ, but can be defined using the same set of characteristics are called as entity set. Those entities which have the same attributes are called as entity sets. So a set of all entities of the same type are called as entity sets. Similarly, set of relationships of the same type are called as relationship set. So this is a key point to be noted. This slide should be remembered throughout your career. That's why I was focusing here a lot. Again, revising back, it should be very clear for us. Entity is anything that exists in the world and can be distinguished from other things. Similarly, relationship is nothing but an association among the entities. So, the diagram is mainly composed of how do you depict entities, how do you depict relationships, how do you depict the attributes. To depict those things, we use certain notational figures. For example, we'll use rectangles to represent entity sets. We'll use ellipses to represent attributes. We'll use diamonds to represent relationships. We'll use lines to say that there is a link between the relationship and the entities. I hope till here it's clear for everyone. Now, last thing that is for us is mapping. Mapping cardinality says if there is a relationship, how many entities from this uh, entity set are going to participate in this particular entity set. For example, students are there, colleges. 60 students can study in one class. Let us say instead of class, 60 students can study in one class. So 60 is to 1 is the mapping cardinality. Similarly, in my class, there can be a maximum of 100 students in the WebEx. So one faculty is to 100 students. That 1 is to 100 is the mapping cardinality. So mapping cardinality basically says how many entities from one entity set are going to participate in another entity set. So based on these, we will try to have some figures. For example, here, customer is there, which is one entity set. Account is there, which is another entity set. Customer is depositor into the account. That particular relationship is a depositor. We are using a rhombus or a diamond to represent it. Now to define the customer, we are using customer ID, name, customer street, customer city. These are actually the characteristics which are used to define the customer. Characteristics are also called as attributes. No? For the account, what is the account number and what is the balance? These two will be used for defining what is the account entity set. Similarly, if I wish, I could have given for depositor also, but usually we'll try to skip it off. Why we'll skip it, I'll explain when I'm trying to show how do we reduce the diagram into tables, how we convert one model into another model. So here comes the relation. In relation model, we'll save the data in terms of tables or relations. Each table will be composed of columns